Hi, everyone, and welcome to today's live online Lunch and Learn. Speed, extendability, and choice. Why NDR wants to be open. Sponsored by Corelight. My name is Dustin Pollock of SANS, and I'll be moderating today's webcast. To help make the most of this presentation, I invite you to join our bonus sessions presentation Slack workspace. You'll find a link here in just a minute within the Zoom chat box. Today's featured speaker is Greg Bell. If during the webcast you have any questions for our presenter, please go ahead and enter them in the Q&A window located on the control panel or in the Slack workspace at any time. Please note that a copy of the slides and recording will be made available for later viewing in the SANS webcast archive. Now I'd like to turn the webcast over to Greg.
Great, thank you, Dustin. Hello to everyone who's joined, and thank you to SANS for the opportunity to speak. It's a pleasure. Good morning, good afternoon, good evening, wherever you may be. Let me get started with my slides. Let's see. There we go. All right. It's a particular pleasure to speak in this forum because my understanding is that it is historically attracted a lot of folks in the federal space. And I spent most of my career actually with .gov in my email address. I'll introduce myself briefly and then get to the topic that I really want to cover, which is about network detection and response, a relatively new category introduced by Gartner, but it has a rich history, and that's what I want to talk about. There's so much momentous news in our screens over the last week. I'm not going to talk about the Electoral College. I'm not going to talk about COVID, but I will spend a couple of slides talking about the implications of this talk on the SolarWinds breach. So if your life has been dominated by understanding and responding to that big event in the cybersecurity world, I will have a little bit to say about it I think is relevant. So hang on for that. First, though, a little bit of an introduction. I spent most of my career as an operator and a very mission-oriented person in the Department of Energy complex. And in fact, I never really expected to co-found or lead a startup. That's what I'm doing now. I moved recently into a different role, overseeing open source development and engagement for our company. But at heart, I think I'm a federal mission person, like many of you. I started as a frontline network engineer in the DOE system at Lawrence Berkeley National Lab. And that was a great place really to learn about networking and all of its complexity, especially on a global scale, and about cybersecurity. Pretty much every day I worked in a data center where on this telco rack, the following signatures were recorded. This says, if you can't read it, it says on this site, the Hanover hacker was caught August 1986 through July 1987, signed by folks who used to be my colleagues, including Cliff Stoll, who wrote this wonderful book, The Cuckoo's Egg, which tells the story of one of the very first sort of international hacks and its detection and response. And if you haven't read that book, I urge you to do it. It's fast, it's funny, and it tells you, it's amazing how little has changed. I mean, certainly a lot has changed about the world, the internet, and offensive and defensive techniques, but there's a lot of commonalities, even as I think about the SolarWinds situation. So that history was always in my mind as I climbed the ranks in the Department of Energy. At the end, I was leading the mission network, effectively the ISP for the Department of Energy that was global in scale, and it supported the complex missions of the DOE, large-scale science, but also nuclear weapons stewardship and energy science. So that I like to say was the best job in networking. Somewhat unexpectedly to my family and myself, I left to found a cybersecurity startup called Corelight, where I currently work as well. And the reason for that is that we believe, the co-founders and I, that there was a very significant commercial opportunity around the commercialization of an open source tool that was part of our bread and butter at Lawrence Berkeley Lab called Bro. For most of its life, a couple of years ago, it's been renamed Zeek. And so I try to say Zeek. You may hear the syllable bro escape my lips, but and it's probably a bit better known as Bro, but the name of the project now is Zeek. And you can think of Corelight really in this heritage of companies that all work to commercialize a popular sort of network-centric cybersecurity tool developed really in the 90s, because these are very battle-tested tools by this point. Snort giving rise to SourceFire, Nessus giving rise to Tenable. Great companies that we admire, and we see ourselves as following in those, venerable footsteps. Now, if you haven't heard of Bro or Zeek, maybe you have, maybe you haven't. You've probably heard of SolarWinds by now. And my favorite tweet of the weekend was one that came out from Scott Runnels, who's a really skilled and I think influential security practitioner at Mandiant, who let this little tidbit of their own process out on Twitter Sunday night. We leveraged a lot of tech. And this investigation only solidified my belief that an NSM, network security monitoring stack, isn't complete without Zeek. Obfuscatory, that's a tough word, attacker actions had a hard time hiding from all the research done by the folks at Corelight. And he is not saying that Mandiant or FireEye is a Corelight customer. They're not actually. But it just so happens that the founders of the company created Zeek, open source Zeek, and all the committers to the project work for Corelight. So Corelight is effectively the economic model right now for the open source Zeek project. So that's just a shout out from Scott. So we were just delighted to see that. And it really helps us as mission oriented people feel great about the work we do on the open source side, but also the commercial side. That's a very important impact and we're proud of it. But a little more from a sort of a more descriptive approach, what Zeek is a fantastic way of making sense of network traffic and all of its complexity and high volume. It is generally replaces either NetFlow or PCAP or both for many, many applications. That's because it has about 100 times more data richness than NetFlow, which is quite minimalist, and it's about 100 times smaller to store than PCAP. So it's kind of like the Goldilocks between those two more extreme formats for recording what happens on a network. It's sort of just the data you need from network traffic for security operations. And so it is that layer, network traffic analysis, sometimes called DPI, but it's also an ecosystem of applications for doing mostly behavioral detections from network traffic. And that ecosystem is growing very rapidly. And a lot of important organizations are contributing to it. And we're very grateful for that. MITRE has contributed, Amazon, Salesforce, the National Lab System, Yahoo, lots of other companies. And in fact, the software is widely used by tens of thousands of organizations globally, including lots of parts of the federal government and many companies, probably skewing towards larger companies and organizations, research labs, research universities, and the like. So that's what Zeek is. The data is special because it is very densely interlinked and well indexed. And so when it ends up in a SIM, which is where it typically goes, incident responders and threat hunters who are trying to get to the truth of what happened during a breach or afterwards can work a lot faster. So it helps tell stories. It helps get to the narratives that matter and that influence our actions and influence our perception of risk and disclosure obligations too. So it's very special data that's well organized and rich and interlinked. So that's kind of what we're doing at Corelight, is making that really powerful open source tool available to enterprises that don't want to implement the open source Zeek project, because it's a bit of a Unix power tool. It's not so easy to scale and manage all by itself. Okay, so there's a little bit of latency on my screen. Let's see if Zoom will wake up. Okay, so now let's get started with the sort of discussion proper. That was my introduction. I want to say when I was a network operator and I was buying things from companies rather than selling them, I was a little bit baffled by the security landscape. And I think that's because we are sort of tempted by companies to take a product-centric view of security. And this is a famous slide from Momentum Cyber that sort of sketches out just a fraction of the security landscape if you take a product-centric view. All these logos, so many of them. It's also, to be honest, it looks a little bit like the floor map for RSA as well. It's a little bit hard to understand what they're all doing. Their claims are significantly overlapping. If you go to RSA, you see a lot of undifferentiated claims, and it's frankly kind of confusing and baffling. We find that our customers are taking a different view of security. And let's see if I can I'm having this latency problem again. they tend to take a more data-centric view as opposed to the product-centric view here. If you take a data-centric view of security, and by the way, so many human endeavors are being transformed by data, data science, as we all know, medicine, finance, a lot of other things, of course, security as well. If you take a data-centric view, you can really think clearly about the sources of data you have access to do the security work you need to do. So the sources of data are relatively small. They're a lot smaller than the number of companies available. And almost from first principles, you need data from computers, from hosts, containers, maybe IoT devices, but data from systems. You need data from the network. And generally we say data from systems is for depth and data from the network is for breadth and ground truth. And you can also get data from external or internal sources of intelligence. There may be some other data available too, but it's only 3 or 4 sources. And in most organizations, that data gets blended into a SIM or a data lake, some analytics pipeline where workflows make use of it, workflows in the SOC or other kinds of workflows. So what we do at Corelight is just to focus on this sort of middle row. We want to make sure that the data that we derive from the network for our customers and for the community too is as good as it can possibly be and can really accelerate and improve security outcomes. That's where we're focusing, not from the host, not from Intel sources, but from the network. And you might say, is the network data relevant anymore? And the answer is a few years ago, I believe there was sort of an overcorrection towards the endpoints in companies. And I think some practitioners were making the claim that you don't really need network data anymore. I feel there's a real shift in the swing of the pendulum towards a more balanced perspective that includes and synthesizes endpoint data with network data and Intel data too, for that matter. And that's appropriate. I would never claim that endpoint data is unnecessary. It's vitally important, but we do need network data too to supplement this sort of 3-part data strategy that I mentioned. And I feel that happening. I feel it happening when I read the news, when I talk to customers, when I talk to our team. And I think it's a good thing. There's a couple of reasons for it. One reason is somewhat accidental, but Gartner and other analysts have a big impact on the market. And Gartner did publish a market guide for network detection and response and really solidified and named that category NDR in June. I'll talk a little bit in this conversation about the history of that. That didn't come out of nothing. And Gartner also popularized and has for some years this idea of a SOC triad that includes the SIM, EDR, sources, and NDR. And NDR and EDR have a nice, parallel structure too, with 1-letter difference. So that's one reason I think the pendulum is swinging. And another is a rising consciousness that the number of unmanaged devices and frankly unmanageable in the internet is still growing very rapidly. And from data I can find, and it's hard to find accurate data without spending a lot of money, and it would be proprietary, but from data I can find in public domain, this transition has already occurred. So the number of unmanaged, unmanageable devices has exceeded the number of manageable and managed devices by a significant margin. That will continue because of the rise of 5G, the relative, the drastic reduction in the cost of adding wireless connectivity to every device in the world, GPS connectivity, et cetera. So this trend is here to stay. And I call it U greater than M, unmanaged greater than managed. And it's funny, some of the EDR vendors are privately acknowledging this. I had an EDR executive talk to me a couple months ago and saying NDR is always in the top 3 topics people ask us about as an EDR vendor, which I found to be fascinating and really substantiates that thesis of the swing. So it got me wondering, and I'm proposing a balanced perspective on NDR versus EDR, but it got me wondering, is there any precedent for a time when all we had really was network data, when U was much greater than M, and we had to build security tools really focused entirely on network data? And the answer to that is absolutely yes. There's probably multiple examples, but the example I'm familiar with is the environment that I came out of, which is the environment of global team science, which, supported by the US Department of Energy, National Science Foundation, by the European Union, and by dozens of similar national science funding bodies around the world. That's precisely the culture and the history that Cliff Stoll was embedded in when he wrote his book, or when he did the work described in his book, The Cuckoo's Egg. In fact, if I'm right in my memory, he was actually a physicist turned computational and then security scientist, which is a really common path actually in the national lab system. So this is a great precedent for a world where the network matters so much. It's a world of not understood by a lot of people, actually. It's a world of very large scale instruments, projects that last decades, not months or years, fundamental discoveries, lots of Nobel Prizes. The Department of Energy funded research, or its predecessor agencies, funded research that led to about 100 Nobel Prizes, not just one or two, but probably over 100 at this point, over the course of its history. So it's a cool, interesting world, but it's daunting when you think about the defensive practices that are necessary, because there are so many participants from so many countries. They shift all the time. The network pipes are enormous. The participation in these collaborations is very, very complex. But they are very productive. The supercomputing center at LBNL, this nice building on the right where I had my office before I left to join Corelight, publishes 2,200, the researchers there publish 2,200 scientific papers a year, 7,000 users. So very, very important linchpins for the engines of scientific discovery we depend on, like for the COVID vaccine and for other things that matter to us. The devices to protect include sequencers, genetic sequencers, accelerator beamline components, supercomputers, telescopes, and of course, servers and laptops and phones. But a lot of the stuff on the left with embedded systems they're not going to run, CrowdStrike or SentinelOne. The networks are just amazingly fast. That's what I really liked about my previous job, was building really, really fast networks to accelerate science. This one project, a really interesting one called the Square Kilometer Array, which is will be, when it's finished, the largest radio telescope in history and spans 2 continents, Southern Africa and Australia, is planned to spit out 157 terabytes of data per second. So that's about a petabit of data per second, not per year. That'll be reduced by supercomputers, but it still gives you a sense of the volume of data. That amount is probably a significant multiple of the cross-sectional bandwidth of the entire internet. I mean, it's a really large number. So what if you're a defender working in this context? Well, it's a little challenging. You've got a lot of stuff happening. New protocols, techniques, architectures are born all the time. That's the work product of scientists and your customers. You've got bleeding edge performance. You can't manage the devices. It's hard to define what normal traffic is. Inside and outside as categories don't really matter. And it's critical to minimize dwell times, because these are very tasty targets for all sorts of criminal and nation state activities. And so what developed in that environment were really, really good open source tools for observing what happened, because you couldn't always prevent everything from happening, and then habits and structures for community defense, for working together. And so that is really the prehistory in my mind of this category that was created by Gartner. The acronyms have shifted. We used to call it network security monitoring, then NTA, network traffic analysis. But I think this is the root of it, or one important root. And it's not just a kind of eccentric theory on my part. It's just factually true that Zeek, the project that we're commercializing, and TCP dump, which is just a ubiquitous tool for capturing and monitoring network traffic on the command line, were both written by grad students working at LBNL, where I used to work, in a group that served accelerator systems folks. In close proximity to all the particle accelerators. That was Steve McCann for TCP dump, libpcap, and Vern Paxson, my colleague, co-founder. And then at roughly the same time, within a few years, other projects with slightly different objectives, ambitions were invented. Snort, Suricata, Security Onion, a great community project led by Doug Burks to sort of consolidate a lot of these projects and techniques together. Nessus as well. And these were embraced by lots of organizations, government entities, very quickly by the late 90s for sure, R1 universities, national labs, et cetera, and commercialized by a lot of companies. And the definitive book on this, I think, is this one called The Practice of Network Security Monitoring by my colleague at Corelight, Richard Baitlick. He's also written many books, blogs, very well known, over 50,000 Twitter followers, just a terrific person. And he's been essential in the history of this category. But I think it's important for us to know, especially in the federal space, it's really more than a product category. This network detection and response, as it's now called, is really a design pattern. And by that, I mean that term is a kind of cool term I like. It comes first, most recently, from this great book and classic on object-oriented software. But before that, it's just a term from architectural history popularized by Christopher Alexander at Berkeley. And he was just making the point that in architecture, there's a lot of structures that you cannot say any culture or person invented. The door, the front porch, the hearth, the family room, the atrium. These are things that were independently invented by a lot of cultures because they kind of had to exist. And that is the way I think about NDR. It's a kind of design pattern that was pulled together by universities, national labs, independently, and by a lot of developers working on these great projects, but it kind of consolidated into a stack of, PCAP, packet capture, Zeek for sort of value neutral metadata, behavioral detection, Suricata or Snort for signature-based detection, and a few other components as well. And there's a larger ecosystem around it. So it's owned by, in a sense, by us, by the community, by the people who contributed to it. And so it's not owned by security companies. That's, I think, the essential point. You can think of it as a stack. I sort of described it verbally, but this is the way I would describe it visually, leading from network traffic all the way up to insight, analysis, action, maybe automation at the very top. But these middle layers really have these deep open source science origins. So my thesis here in this talk is that that NDR is really a design pattern. It's not a product category that vendors gave us, and its heritage is open, and really that its future ought to be as well. And that's a very good thing for operators and for practitioners. And I really still wear that hat most of the time. I have that identity mentally anyway of needing to buy a lot of things from companies, often being disappointed, and really taking the operational view on cybersecurity technologies. And I think there's three critical reasons why we want NDR to stay open. We want the data formats to be open and extensible, and we want everything around it to be as transparent as possible. The first is speed. We really shouldn't have to wait for a vendor to prioritize an event, a protocol, a TTP, an exploit. Attacks are disclosed very quickly, as the last week has proven. And in a couple slides, I'll explain how the openness of the structure I described led to a really fast outcome in terms of actionable insight. Speed is critical. When a breach has been discovered, especially if it's serious, the clock is ticking. Extensibility is a really important feature, and I guess I would combine that mentally with the notion of standardization. So we really need and want a single sort of de facto standard for network data, the summarization of network data. We don't want to have, if we're operators, 5 different data formats, one for AWS, one for Azure, one for vendor A and vendor B on-prem, one for remote offices. That would be a disaster. How could you stitch together the narrative of an attack? So we want a single normalized de facto data standard, and one that we can extend and customize and combine. So that second part is very important too. Maybe the data format needs a little tweaking for my environment. Maybe I want to add a few fields. Maybe I don't care about these fields. Maybe I want to combine this data with other data that I derive maybe from my configuration management database or something like that. But the data needs to be both standardized and extensible to be useful, I think. And then we want choice, transparency, autonomy, and community leverage in the detections that we deploy. So I think the era of black box detections, closed and proprietary data formats ought to be drawing to a close. As defenders, we really want to understand what logic underlies detections. We want to choose this, not that. And I say this, again, maybe generalizing from my own experience in the segment and the missions that I supported. There are organizations with very small security teams that might not prioritize transparency and autonomy quite as much. But for the segment our company serves, and I think for a lot of federal practitioners as well, these values are very important, and true for enterprise practitioners too. So do we have any evidence that what I'm saying is actually working. So is this, does the ecosystem exist? And do these values get embedded in it? And is it thriving? And I think if we just take sort of the narrow view of the Zeek ecosystem, which is my community of origin, um, the the news is very, very good. So there's a large and growing body of people who contribute parsers and detections to the commons. And those are very rapidly disseminated and used by our customers at Corelight, but also we open source a lot of stuff at Corelight we don't commercialize, and so they can be used by people who deploy open source Zeek. This is an example, this rather busy slide just records some of the detections and parsers that were added to the community in the last year, detections on the left, parsers on the right. The little padlock icon represents areas where the encrypted traffic streams are of interest. So they're relevant to the analysis or parsing of encrypted traffic streams. And if you look at sort of the middle column, you just see how many of the reboot the internet vulnerabilities and CVEs of the last year have been transformed into detections, free detections and open source detections for our community to use. From the F5 big IP vulnerability, the recent WebLogic vulnerability, the bad neighbor attack, zero logon, Eternal Blue, curveball. If we think back to the era before RSA, before COVID, if we can think back that far, and then lots of improvements to the parsing of especially encrypted protocols. So that's good news. The other thing that's happening in our community, in the sort of open source network security community, is more and richer interconnections between projects, which is really cool. So we're seeing the ecosystem get interconnected. So connections between OS Query and Zeek, Zeek Agent and Zeek, between Sigma, which is a kind of universal language for writing SIM queries, and Zeek. And this community ID concept on the left, contributed by our developer, Christian Krybeck at Corelight, is just a fantastic and very simple idea, a sort of standard for flow hashing, so that whatever network tools you're using, OS Query, Suricata, Moloch, Elastic, Zeek, OS Query being, of course, an endpoint tool, but to the extent that it's looking at network traffic, the same hash gets applied to every flow. So you can pivot from a Suricata alert to the Zeek metadata in a SIM as a result of this simple community innovation. Okay, so that's all good news. But let's think about the events of the last week, and remember, before you had heard, before you were furiously Googling SolarWinds over the weekend, you might have been Googling information about the FireEye disclosure. FireEye very transparently and forthrightly, and in a very detailed way, disclosed the sophisticated state-sponsored adversary that that broke in through FireEye defenses and captured the red team tools, stole them. And FireEye did the right thing. First of all, they released a lot of information, about the process of the attack, but more importantly, what was taken. And then immediately, the sort of open security and to a large extent open NDR ecosystem took over and moved very quickly. So FireEye, what did they do? They released a press release, but more importantly, they released the indicators in open formats into GitHub. And so if you look at these logos, I'm not going to explain what every one of them is, but they're familiar to some of you probably. And you might recognize Snort as a logo that I identified as part of the classic OpenNDR stack. So there were Snort signatures, there were Yara signatures. These went straight into GitHub, and almost immediately the ecosystem of folks who can make use of those open indicators and detections kicked into high gear. So many examples, but one thing that happened is that Proofpoint used the Snort signatures. They tested them at scale. They improved their syntax a little bit. They added value. Then they open sourced them into their ET-open rule set. And so that got out not only to Proofpoint's customers, but to other companies and their customers. So at Corelight, we very rapidly took the ET-open rules and shipped them out to, made them available to our customers who have licensed Suricata on our products, since we commercialize Zeek and Suricata as well. So that's just one line of influence that happened very rapidly, just a matter of a day or two, I think, to go from the disclosure to Corelight customers. Of course, other companies, many companies and their customers benefited from the ET Pro release, and then lots of other companies and their customers benefited directly from the GitHub release. So one another example is SOC Prime, the folks behind the Sigma standard that I mentioned earlier. They took a different part of the release from FireEye, and they transformed the HXIOC indicators into Sigma rules that could be used in any SIM, whether you use Splunk or Elastic or Devo or Humio or Logarithm or Exabeam, Securonics, whatever it might be. There's so many. Chronicle, these signatures work across SIM. So that has a very important impact as well. There's lots of other companies, dozens that I haven't named here. And then another route that's occurring is that companies like Corelight are going directly to GitHub, getting indicators and using that to build maybe more sophisticated detections on a slightly longer time scale. And so this repository of IOCs is going to be incredibly useful to practitioners and researchers for a long time, thanks to that simple decision that FireEye made to release the indicators in open source format. And then if we fast forward to just a few days later, the events disclosed on Sunday, I think it was. What's amazing is that it's a different breach, maybe related, maybe not, but it's sort of different breach with massively greater impact. And I think you've all read about it. I don't need to repeat what happened here, but the disclosure path, and it was just identical. Just almost exactly the same kinds of indicators were released, almost exactly the same workflow that I just described here occurred with Proofpoint and Corelight and SOC Prime and many other companies. Lots of them have blogged about it. I've just listed a couple of them. And in this case, especially that direct line between GitHub and researchers, I think will be even more powerful. So this decision by FireEye and the availability of this ecosystem to both describe what happened and to consume and transform and deliver further value is maybe the hidden story here. I mean, I think there's going to be a lot of analysis of what happened, of defensive techniques and detection techniques that failed, things that went well. We're going to learn a lot, and we still don't know anything really, to be honest, about the whole scope of the breach. I'm sure it's larger than we currently imagine, but as that unfolds, and as we learn sort of the local lessons, don't forget the deep structural lesson here and the formal lesson, which is that the open APIs, open data standards, willingness to release in the open, the availability of GitHub had a very substantial impact on how the story unfolded, and a very positive impact. So it's really no better illustration of the need for speed, extensibility, and choice than the events of the last week. So I'm grateful to that extent for these events as a kind of exclamation point to my message here today. So let me wrap it up. We can leave a little bit of time for questions if you've got them. Wrap it up with just a few final thoughts. One is that organizations really are, we see it in our customer conversations, they're taking a more data-centric view of security. And I just, as an operator who was baffled by the product-centric view and frustrated by it and confused by the language and, a little irritated, frankly, that I had to spend too much time understanding it and not fulfilling my mission of my job, I find this to be a really great development. The development of just a more simplified data-centric view of security. Again, we at Corelight are working to consolidate and commercialize that open NDR stack. So we're really working at this sort of middle row here, the green row. We have solutions on-prem, in the cloud, in VMware environments. We'd love to talk to you if you have needs to improve your network security game. But it's certainly easier to talk through the lens of this diagram than through the lens of Momentum Cyber diagram, the product-centric lens. Let's see. The latency returns. There we go. Next closing thought is that the pendulum really is swinging back. It's not enough really to just assume that endpoint security will take care of all your security needs. It's a very important component, but we really do need a balanced approach that includes network-derived data for breadth and for ground truth, endpoint-derived data for depth. And I would remind you again of that great Scott Reynolds tweet at the beginning, and he had a follow-on tweet too, that shine the light not only on the importance of Zeek data in understanding the mechanisms of that SolarWinds attack, because they were very subtle, and the detection work there was just exemplary. But it's not just Zeek itself, but it was the availability of Zeek data for east-west traffic to really understand how lateral movement worked and privilege escalation worked. So the SolarWinds breach is just a really great example of why we need a more balanced perspective on security that includes network and endpoint derived data. And my final, I know it's a busy diagram, but I think I talked us through it before, that open NDR is really the future of this category. It's the right idea. It connects with this sort of broader idea that John Lambert at Microsoft has called the GitHubification of security. Just the rise of practices around open standards, open APIs, and sharing. I can't share everything in security, but I think this workflow that I've described over the last week really points to the value of sharing what you can, especially around indicators. And it does give us the benefits of greater speed, the extensibility we need to localize solutions for our own missions and our own environment, and the choice and the autonomy to really decide what's important to me, what's not in my environment, and really to understand what a technical solution is doing. And I think that gives us a few minutes for questions. So I want to thank you. I'm happy to answer questions. I want to say in advance, this world of security is broad, and I'm not an expert by any means in all aspects of it, but I'm happy to answer questions about these topics or others if you've got them. And I'll stop sharing for now.
Greg, we do have some questions that came in. The first one is someone they're mentioning that they're seeing indicator-based detection, and they want to know about network behavioral detection in an advanced version, if you have some insight into that.
Yeah, and maybe first sort of describing the difference between those ideas. So classically, tools like Snort and Suricata were looking for signatures, like bit patterns on the wire. They can do more than that now. They have a little bit of sort of Zeek's parsing ability built into them. But classically, there's this division between two categories, sort of signature-based detection, which really looks at the content of a single packet or a couple packets, and behavioral detection that may take into account the state of millions of concurrent connections, or maybe time elapsed over half an hour or more. It may be a lot more complex to define a behavioral detection. Like this user, for ransomware, the behavioral detection might be this user seem to download a bunch of files at low entropy, they're not encrypted, and then upload files at high entropy, they're encrypted. And so that's hard to capture with a signature, but easier to capture with a behavior. So the question is, the early releases are around signatures. Are we going to get behavioral detections? And I will say Zeek, the platform we're commercializing, is really, that's its bread and butter. Besides the value neutral data is sophisticated behavioral detections. And our research team works on those all the time. In fact, we have a new collection of behavioral detections for a particular MITRE attack column coming out just in about a month. So we think about that a lot. I'm certain that this disclosure will lead us to develop behavioral detections relevant to this particular attack vector in the future. I can't tell you when it's going to happen, but I think that this attack is so momentous in its impact that every research team will be thinking about how to capture not just the surface level signature, which is a lot better than nothing, but the deeper behavior, especially when it comes to privilege escalation and lateral movement. So the answer is yes. That was kind of a long-winded answer, but the answer is yes, but I can't tell you when.
Awesome. And then that is all of the questions that we have so far. But Greg's email, if you want to reach out to him directly, is just greg@Corelight. So go ahead and feel free to connect with him one-on-one.
Yeah.
Greg, did you have anything else that you wanted to mention to the audience or anything as we head out?
Yeah, I'm just happy. I would underline, I'm a pretty accessible person. Just shoot me a note, Greg at Corelight, if you'd like to talk. If you work in the federal side, thank you for your service to your mission. And if you work outside the federal side, I know it's been a busy week, so that probably affected the attendance here a little bit too. There's a lot of people focusing on this operational crisis. But thanks for your work on that and for everything you do to defend the interconnected world. And let us know if we can help here at Corelight.
Awesome. Thank you so much, Greg.
Sure,
Also,
my
thank you
pleasure.
everyone for attending today and to Corelight for sponsoring the webcast. This will be available in the archive, so you can download the presentation and view a copy of the recording. Just go to sans.org/webcast And until next time, take care, and we hope to see you all back again soon.
Thank you.